Hello everyone, I am Ishani Samaravira. Here I am going to present my research project Human Facial Expression Analysis and Emotional Status Recognition. Why we need a facial expression analysis and status recognition system? In the present era, customer feedbacks are really important in a business. Collecting customer feedbacks after giving the service is really helpful to enhance the service. It is difficult, time consuming and not accurate if asked the feedbacks verbally. Also, in a workplace, by placing a camera at the fingerprint scanner, can monitor facial expression of the employees. Those data can predict whether they are happy to work to the company or not. Also, to detect the mental status of a driver and gives an alert if the driver doesn't in a stable mind to carry the vehicle. To detect mental condition of a criminal for investigation and to determine patient agony of a medical patient and inform that to the relevant medical staff in an emergency. Those are the use cases of this system. Let's go to the literature review. In this research, identify two approaches to build such a classification model with static images. The first approach is analyzing the facial landmark differences. The second approach is using deep neural network with large data set. Let's see about analyzing the facial landmark differences. Calculate and identify locations, regions of interest or facial landmarks to pay attention to. Calculate Euclidean distance between these points. For different expression, taking the distance as input vector. Using SVM, doing the classification. My first literature review is about facial component extraction and expression recognition in static images by Mamita Pukharpam. Identify the region of interest, classify by them with SVM. Problems are it use very small images set for training. Identify the skin regions, uses HSV to identify the region of interest. It required additional processing and its accuracy can be questionable. The second literature review is about appreciation of customer satisfaction through analysis, facial expression and emotion recognition. It's by Mauli Smale and it used the Jaffe dataset. It contained 213 images from 20 different Japanese girls. Facial landmarks 22, distance is 19. Problems are the dataset is limited, the dataset is not natural, and only 10 people has posed for their expression. Let's see using a deep neural network with a large dataset. It uses a large dataset, usually uses a CNN. Feature extraction and mapping is done when the CNN is being trained. Usually take a large time. Resource consumption is high. This is the third literature review. It's a facial expression recognition system to predict emotions by Kaustav Manipathak. It uses deep CNN to identify the expression to improve the spontaneity. Dataset is consists of multiple public datasets. Movie snapshot model expression datasets such as Jaffe, personal photos, and public images available in the internet. Let's move on to the methodology and prototype. Project execution divided into three stages. First one is the dataset, second one is the classification engine, and third one is the classification evaluator. Let's move on to the dataset. I used the dataset named as FIR 2013. It's a freely available dataset in Kaggle website. It contains randomly collected pictures from movies and incidences. Images are very small in size, 48 by 48 pixels. It contains 35,887 images. Let's talk about the problem with the dataset. The dataset is not equally distributed. Images are too small, so the subtle changes in faces are already lost. And original classification has problems. Correctness of some images with their assigned emotion is questionable. Let's move on to the building the classification engine. This is the structure of the classification engine. Trained data and the test data is fed from the file system. Image data generator is used to enhance the image stream with small changes like flipping, rotating, tittling, etc. I use the technologies as Keras, TensorFlow, and Python. The trained model is saved to a file for later use. The structure of the convolutional neural network is like this. Training CNN on local machine. This is the spec of my laptop. It took 9 hours and 41 minutes to train my model. It's difficult to experiment due to the longer running. Training CNN on the Google Colab. It's a free SaaS product provided by Google, a Jupyter notebook in a cloud. Supports GPU and TPU runtimes. It took 20 minutes with GPU to train the model. Training CNN on AWS Cloud Notebooks. It's a paid SaaS product provided by AWS. Another Jupyter notebook in cloud. GPU kernels in different performance flavors. Comparatively expensive for higher GPU servers. For the model, it took 18 minutes to train the model. Jupyter Notebook is a web-based Python runtime environment where we can run programs from the browser. The program can be executed either in a local or cloud-based on the notebook. Google Colab is an example. AWS Notebook also an example. Here is my code for training in a AWS Notebook. This service is cost around $8.64 per hour. This is the report. In the method count exp, it just print the image counts of trained dataset and the test dataset. When I give image set to the image data generator, it does small adjustment to generate more images from them, like tittling, flipping, etc. With image data generator, we create the test dataset and the trained dataset. In the get model, I created the neural network. It contains Convo 2D layers which make the neural network a convolutional neural network. Then some additional layers to normalize and further tune the results. Then in the fernet.fit, I trained the neural network. I have set only 60 approaches as I don't see significant improvement in the training 50th approach. Now it's running. This is the log. Training. Let's talk about classification evaluator. This is the structure of the classification evaluator. Save the model and the neural network is given as an input. Live images are taken from the webcam feed and fed into the application. The application then classifies the expression of detected face and put it in the text form. Now I am going to run my program. It open up the web camera. Now my facial expression detected as neutral, and I'm going to change my expressions. This is a video feed, so it's not always uh, guess the expression correctly. This is how it works. Here I am going to run my second program. This program doesn't open up the web camera. It just loops through a given image set. Let's see how it works. The first image detected as a sad image by the program. The second image also recognized as a sad emotion by the program. Third image detected as a fear emotion, sad emotion. This one is also recognized as a sad emotion. This one is also recognized as a sad emotion. Neutral emotion. This image also recognized as a happy image. This one is recognized as a sad image. This image is recognized as a happy emotion. Happy emotion again. Again it's a happy emotion. The program recognizes it as a happy. This image recognized as a angry image. Sad image. Likewise, it's looped through the image set. Happy face. Happy face. Surprise image. This image is recognized as a sad image. This image also recognized as a sad image. This one is recognized as a fear emotion. Sad emotion. This one is recognized as a happy emotion. This one recognized as a sad emotion. Happy emotion. Angry emotion. Neutral emotion, but it's not neutral, but program recognize it as a neutral. This one is recognized as a angry image. This one is also recognized as a neutral image. This one is recognized as a happy image. This face detected as a sad face. Also recognized as a sad face. This one is recognized as a sad image, but it's not sad. Sad image. Sad. This is how it identify the emotional status. This image recognized as a happy image. That's how it works. Let's talk about the evaluation. This is the confusion matrix for training data. Here you can see a less amount of discuss images has identified as a discuss image because there are a small amount of discuss images in the data set, and you can see happy happy faces recognized as a happy image in 1847 pictures. It's comparatively high, and the accuracy is high compared to another emotion. This is the confusion matrix for training data as a percentage of correct value. Here you can see discuss images have low accuracy due to small amount of data, but happy emotion has high accuracy compared to other emotions because it has high amount of pictures included. This is the confusion matrix for test data. Here, zero discuss images recognized as discuss image from an happy faces detected as a happy faces in 450 pictures. Comparatively, it's high, but discuss images are very low accuracy. This is the confusion matrix for test data as a percentage of correct value. You can see here happy images are in in green color. It is 25% of rate has the as the accuracy. Let's talk about the accuracy. Why accuracy is too low? Training dataset is not evenly distributed on classes. Discuss class had the lowest data count and had the lowest accuracy. Happy had the highest accuracy. Dataset images are too small. Subtle changes cannot be visually seen. Those images are size of 48 by 48 pixels. It's really small size. Possible improvement to the algorithm. How we can improve the accuracy? Using higher image quality. Using dataset with images with a higher image quality. 3D imaging. Using multiple images construct 3D perspective of the face will return better results. Video feeds. Instead of a single image frame, multiple frames across a time span to capture the facial muscles and movements. This is how we can improve the accuracy of the system. Thank you.